So, have you ever stopped to wonder how we experience the world as, well, a single, seamless reality? I mean, when you see a friend laugh, you don't perceive a shape and then a color and then a sound and then motion all separately. You just see your friend laughing. But here's the thing, your brain is getting all those signals in different pieces. So how in the world does it put them all together? Well, the answer is one of the greatest tricks the mind has ever pulled off.
Come on, you know you have. You're watching so closely, you're paying full attention. And yet, bam! The impossible happens right in front of your eyes. A coin just vanishes, a card changes. You know it's a trick, but for the life of you, you just can't see how it was done.
You know, our first instinct is to think the deception is happening out there, on the stage. It's got to be in the flurry of the magician's hands or some hidden device, right? We think, if I just look closer, I'll catch it. But that's exactly what the magician wants you to think.
The real secret to magic isn't actually about sleight of hand. It's about exploiting the fundamental way your brain constructs reality every single moment of every single day. Magicians are, in a way, practical neuroscientists. They're hacking your brain.
Okay, so let's really dive into this. The key tool a magician uses isn't a secret compartment or a hidden wire. Nope, it's a technique that directly targets the machinery of your mind.
Now, misdirection isn't just about, making you look over there while the real action is happening here. It's so much more sophisticated than that. It's about manipulating the very systems your brain uses to decide what's important and what's not. It is, for sure, a form of cognitive hacking.
And to understand how this hack really works, we need to look at the operating system it's targeting. Cognitive psychology gives us this fantastic framework for it, the three-network model of attention. Think of it like three different managers inside your head, and each one has a very specific job to do.
So first up, you have the alerting network. This is basically your brain's readiness signal, keeping you awake and prepared for anything to happen. Then you've got the orienting network, which is like a spotlight, selecting one specific stream of information from all the data that's pouring in. And finally, the executive network. It's the supervisor, the boss, and it steps in to resolve conflicts when different things are all competing for your focus.
So how does a magician exploit all this? Well, this right here is the crucial insight. These networks are mostly independent of each other. A magician can crank your alerting network all the way up to 10. I mean, you're on the edge of your seat, totally ready for anything, while at the very same time, they are quietly guiding your orienting network, that little spotlight, to focus on something completely and utterly irrelevant to the trick.
There's this brilliant study that illustrates this perfectly. People watched a video of a pen just vanishing. Now, most of them were alert enough to pinpoint the exact moment the pen disappeared. But when they were asked how it disappeared, only a tiny fraction, just 11% of those very same people could give the right explanation. Their alerting network was totally online, but their orienting network, that had been successfully hacked.
You know, this vulnerability in our attention system, it actually points to a much deeper, much more fundamental puzzle about perception itself. It's something neuroscientists call the binding problem, and believe me, it's happening in your brain right now.
It seems obvious, doesn't it? Of course, the redness and the motion belong to the car. But for your brain, it is not obvious at all. In fact, different parts of your visual cortex are processing these features completely separately. One area is handling the color, another area is handling the motion, and yet another one is handling the shape.
The very fact that you perceive a single, unified red car is an absolutely incredible achievement. Your brain has to actively solve this binding problem thousands of times a second, weaving together all these separate signals into the seamless reality you experience. And this process is so good, you don't even know it's happening.
So the big question is, how does the brain actually pull this off? This is one of the hottest areas of debate in neuroscience, and there are some really fascinating, competing ideas about how this integration really works.
On one side, you've got the early binding theories. These suggest that all the different features get stuck together very early in the visual processing pipeline, almost automatically. But on the other side are the late binding theories. They argue this is a much higher level job happening way later in the process and involving the more sophisticated, big picture parts of the brain that need that spotlight of attention. And within that big debate, two specific mechanisms are the front runners. The first is called feature integration theory. Think of it like a detective. Your attention has to literally go back to the crime scene, those early visual parts of your brain, to double-check that the clues, the red and the car, really do belong together. The second big idea is neural synchronization. This one's pretty cool. Imagine all the different neurons in a choir.
The one singing about red, the one singing about car, and the one singing about motion, all suddenly singing in perfect harmony. That synchronized rhythm is the signal to the rest of the brain that, hey, all these guys belong to the same object. So, to really test these ideas, scientists are moving beyond just observing the brain. Now, they're trying to build one. The goal is to create artificial systems that can solve the binding problem just like a biological brain does.
This quote from the computational neuroscientist Conrad Cording just captures the ambition of this new approach perfectly. See, it's not enough to have a theory that sounds good on paper. The ultimate test is to build a model that can actually perform these complex tasks out in the messy, real world.
So how do they actually do it? Well, the strategy involves creating artificial neural networks that kind of mimic the brain's architecture. They use this clever trick where the boss layers of the network can send messages back down to the worker layers, telling them which specific pieces of information to focus on and stick together. It's like building an attention manager right into the system's code.
And what's really amazing, as you can see here, is the result. These models are incredibly powerful. A single network, built with these binding principles, can perform a whole suite of tasks we think of as distinctly human, from recognizing an object to instantly spotting a different item in a crowd. That's what psychologists call a pop-out search, all the way to tracking a moving target. It's like a unified solution to so many different cognitive challenges.
So, let's bring this all back home. From the magician's stage all the way to the cutting edge of AI, what does all this really tell us about our own experience of the world?
Okay, this is the crucial takeaway. Your brain is not passively receiving reality like a camera. Not at all. It is actively constructing it. It's making best guesses, it's filling in gaps, and it's binding features together based on your expectations and what it thinks is important. The world you experience is a masterful, continuously updated simulation. And this is the final reveal. The binding problem isn't really a problem at all. It's a solution. It's this incredible, invisible process that performs the ultimate magic trick, taking a chaotic storm of separate sensory data, colors, sounds, shapes, and binding it into the coherent, stable, and meaningful world that you inhabit.
And this leaves us with a final, kind of provocative thought. The very same mechanisms that allow magicians to fool us are at work all the time, shaping our reality based on what our brain expects to see. Your brain is constantly selecting what's important enough to be bound into your conscious awareness and what just gets left on the cutting room floor. So it really makes you wonder, what parts of reality are being edited out of your personal movie right at this very moment?